So the steps to use a Karnaugh map are: first, place the output values in the Karnaugh map, right? And then you can use just the ones if you want to. And you put zeros in, that's fine too. Be careful to get the labels in the correct order. This is the tricky part. And you also need to be careful to map it to the right box, right? And then you want to find the largest groups. Remember to use powers of 2 for the group size, 1, 2, 4, 8, etc. And groups can overlap, and you want them to be as big as possible, right? Find the largest group. And groups can wrap around the edges. That means, and we'll have an example of that in a little while, what that means. And then you want to write the terms for each group. Now, Karnaugh maps are not in our textbook. They're an important concept. They just aren't in this particular textbook. So I've written out quite a few examples here in the slides, and we're going to go over them so you'll have some really good understanding of how to use Karnaugh maps. So let's go ahead and do that. Another thing with Karnaugh maps is finding them to work with them. So another thing that's a little tough with Karnaugh maps is being able to find one that you can write in, because it's not truly a table. It has that line and the labels, and it's kind of complex to make. So what I have ended up doing is I created some images for the different size Karnaugh maps. And I'm just opening this up in Snip and Sketch because I can write on it. So if I get that image and I open it up, and you can open up this in any editor that edits images, right? You can open it in Paint, or in Mac, you can open up in the image editing software that comes with a Mac, and then you can write right on the image. So we're going to use that as our way to deal with that. So let's look at these examples. So here we have a Boolean function that has 2 variables, and we want to use a Karnaugh map to find a Boolean expression that matches this function. So we're going to find the ones. Here we have where x is 0 and y is 1. So there's where x is 0 and y is 1. So right there, we're going to put a 1 there. And then the next place that there's a 1 is where x is 1 and y is 0. So x is 1 and y is 0. It's right there. So that's the 2 ones. That's the map, so we've mapped it on there. Step 2 is to group them in the biggest groups that we can group, right? So let's go ahead and pick a color to group them with. And notice we have a group of 1 and a group of 1, and they're not connected at all. So our biggest group is a group of 1. So there's 1 and there's 1. Those are our groups. We don't have any groups bigger than 1. So that's what we're going to have to work with. Then the third step is to write the terms. And this is the trickiest part I have when I'm doing image editing software. I have a hard time writing, right? I'm not very good at writing with a pointer. So, but let's take each group. So let's take this first group, and notice that x doesn't change, it's a 0, and y doesn't change, it's a 1. So it's going to take both of those, since neither of them change, for our expression. X is a 0, so that's the complement of x, and we can either write that with a bar. See, told you I don't do it very well. And then y. Okay, so that's it. The other way to write that would be with x, and when you're writing, you can do it either way, is with that, just with the hyphen, or with the quote after it. So either way is fine. You can do it whichever way works best for you. Then the other group, notice that x doesn't change. It's always a 1. That is then we'll use x for that. And y doesn't change. It's always a 0. So for that, we'll use the complement of y. Okay, so those are the 2 terms. And notice that the terms are multiplication. And then we connect the 2 terms with a plus operation, right? An addition. So that's the expression. And if we go here, sure enough, that's what we get. We get the complement of x times y plus x times the complement of y. And if you're using this kind of method, then you can simply save it, right? You can save it to a location on your computer, and then you can upload that. So when you're working on these, this is one way to do it. You can also do it on a piece of paper and then take a picture of it and just submit it. So there's a Karnaugh map with 2 variables.